Hey, welcome back. And today we're going to move away from linear functions. And as you can see from the title, we're going to look at writing equations from tables of absolute value. And it's really more than tables, all right? So we're actually going to do 6.2. So there'll be a little bit of a review for you there. I can write the equation of absolute value function from a table. But then also we're going to get into 7.2 again, right? I can write the equation of an absolute value function given information from various contexts, right? So that's really what most of the lesson is going to be about today. We're going to start with tables just so that once again we can review the writing equations process with absolute values. And then once again, how can I take that information, all right, and use it in other contexts? So now, here's what we're going to do. We're going to start this lesson with, all right, an exploration to see exactly when we think about our equation, all right, and that's an H there, all right. We know HK is a turning point, and we know A is our rate of change, but we're going to look a little deeper at this and like what exactly does that A value do to our equation. So what I'd like you to do is find 4 different colored pencils for the opener. Black, blue, red, and green would be great if you don't have those specific colors, as long as you have 4 different colors, okay? That's really what we want you to do. And so you're going to do parts A and part B here. And so you're going to graph each of these 4 absolute value functions on the same graph here and get as many points as you can. So you can get several points for the first one, a couple here, a couple here. You may only get 1 set of points for here. Draw those in. Right now, then I want you to do the exact same thing for, all right, part B here, right? So graph all 4 of these absolute value functions on, all right, the same graph here. And once again, try to generate as many points as you can. And then what I want you to do is once you have finished both of those, how do you think the A value changes our graph, right? What does it do, all right, as you look at the difference in the A values in the first set of graphs and the second set of graphs here. So pause the video, do those things, flip it back on, and then we'll look at a pattern and see that hopefully you found the same thing that I saw. All right, so here is my work. So let me show you here, and I used, all right, different colors here. So black, blue, red, and green. And so you can see the black, blue, red, and green. So you can see as the A value got bigger, 1, 2, 5, 10, my graph got steeper, got narrower. It's growing at a faster rate. The rate of change is increasing. And that should make sense. It's going to grow faster. So it's going to be steeper or narrower. Versus on the second one here. Here's my black graph right here. All right. And we call that the parent function. We'll talk about that a little bit, right? And you can see now, notice my A values are getting smaller and smaller. And so my graph is getting wider and wider because it's increasing less fast, right? So the smaller the A value, right, the less fast it's going to increase. So hopefully, all right, that's what you notice, right, that makes the graph narrower or wider, depending on which direction we're going or depending on what A values we have. And so what we really want you to understand, right, is this A value is, all right, the rate of change, right? And if that rate of change is going up, right, if I have a higher rate of change, my graph is going to be steeper. If I have a lower rate of change, my graph is going to be, all right, wider. All right, so now, all right, let's flip the page, all right, and just summarize that, right? So as the A value gets larger, the graph gets narrower. All right, as the A value gets smaller, the graph gets wider, right? It's not increasing as fast. All right, so I'll give you a second to write that down. All right, now, just to review, all right, we're going to jump into a couple problems that hopefully you feel very comfortable with, all right, because we've done this a lot already, and that is writing equations from tables. All right, so when I look at my table here, all right, okay, once again, we want to scan that table. We use that same process. We know this is absolute value, but when we're assessing, we won't, right? Everything's going to be kind of mixed up. So we want to make sure we have a good process. So we always want to scan our table and see if we have a turning point. So in this case, we do. We have the point 2, 6. And what I know is because I have a turning point, it's either absolute value or it's quadratic. So what I want to do now, all right, is jump in and look at those rates of change. So when I look at my left side, my change in x, I can see that all my x's are going up by 1. And then when I look at my right side, my first y goes down by 3. My second y goes down by 3. My third y goes down by 3. I hit that turning point, and notice what happens now. I go up by 3. And so I can see that I have this constant rate of change in both directions. All right, so I have a constant of plus or minus 3 to 1. We can see that the vertex is 2, 6. All right, so I've almost got this problem beat. Now, the issue is, okay, I have two rates of change. Which one do I want to use? Now, once again, let's go back and think about like sketching my graph. I have a negative rate of change, which means my graph is going down until I hit my turning point, and then it goes back up. So if I sketch that, I can see that my absolute value opens up. That tells me that my A value has to be positive. So my equation would be 3, and then x minus 2 inside of my absolute value bars, and then plus 6. All right, and if you write through over 1, that's always good as well. Now, once again, what we're going to do is once we have our equation, all right, we're going to find, okay, what happens when x is 9, right? So if I were to extend this table, what would I get? So y equals 3, and then I have 9 minus 2 plus 6. All right, and then once again, we always take care of those grouping symbols first. So 9 minus 2 is 7. And remember, we have to take the absolute value of a number before we perform any, all right, operations on the outside. So 3, and then the absolute value of 7 is 7, and then I bring down the adding of 6. Do that multiplication. So 3 times 7 is 21, and I bring down the plus 6. 21 plus 6 is 27. So the point would be 927 if I were to extend my table. So when x is 9, y is 27. So really, in essence, what we're also doing is finding another point on this graph that we may not see. All right, so when we evaluate, that is what we are looking for. All right, so let's jump down to number 2 here. All right, so same thing. Let's scan, all right, our table. And if you see a circle, or excuse me, if you see a turning point, go ahead and circle it. All right, and I will do the same thing here. And I see that we have a turning point at -1, -5. That's my vertex. So I'm going to go ahead and fill that in. Now what I want to do is look at my rates of change. Do I have an absolute value or a quadratic? If I have a constant rate of change in both directions, it's absolute value. If not, it's a quadratic. So looking at my x values here, all right, notice I have to pay attention because notice they are increasing by 2 each time. Okay, they're increasing by 2 each time. So we always have to consider, remember, rate of change is change in y to change in x. Consider both sides of your table. Now 5 to 0, I go down 5. 0 to -5, I go down 5 again. -5 to 0, I have changed direction. I am now increasing, and 0 to 5, I increase again. So we can see that we have this constant rate of change, plus or minus 5 over 2, which means it is an absolute value function. Now, once again, okay, when I write my equation, right, I know the vertex, so x minus -1 becomes a +1, and then the -5. And once again, we need to verify, okay, so which of these rates of change do I want? Do I want the +5 over 2 or the -5 over 2? Sketch a quick graph. So once again, I see I have a negative rate of change. So that means I'm going down to begin. I hit the turning point. Then I have a positive rate of change, and so I'm opening up. So once again, we want that positive rate of change because my graph opens up. Okay, now, once again, we're going to predict what the value would be when x is -13. So that would be way up here on our table if we were to extend this way, right? So y equals 5 over 2. And then I have -13 plus 1, all right, minus 5. Once again, let's take care of those grouping symbols first. So 5 over 2, absolute value, -13 plus 1 is -12. All right. Now, once again, we have to take the absolute value before we do that multiplication on the outside. The absolute value of -12 is +12. All right. Now, if you don't know this, all right, you can use a calculator. All right, but 5 halves of 12, all right, would be 30, and then 30 minus 5 would be 25. So the point would be -1325 if we were to extend our table, all right, in the opposite direction there. All right, so hopefully that all seems very, very familiar to you. All right, so now let's flip the page and let's talk about a couple things. All right, so one, when we think about our absolute value function, we have been talking about this guy, right? Y equals A times X minus H in our absolute value bars plus K. We've talked about A as our rate of change. We've talked about our vertex as HK. Now, like I mentioned earlier, Y equals absolute value of X is what we call the parent function. That's like the most basic graph, all right, that we see. All right, the vertex is at 0, 0, and the A value is 1. So that's really what we compare all the other graphs to, is this idea of the parent function. It gives us the basic shape, right, some basic behaviors, and then we kind of compare lots of other things to that. All right, so when you see parent function, this is what we're referring to. All right, now what we're going to do now is once again work in that various context piece, right? We're going to see information, we're going to have to translate that into our equation, all right, of this form. So now if I look at 3a here, we want to write the absolute value equation that does these things. It opens up. So that means a has to be positive, has a rate of change of 1/2. All right, so now I have the answer to this piece, right, from those things. Opens up, rate of change 1/2, so that has to be a positive 1/2, and the vertex is 5, -6. So then that means x minus 5 and then minus 6, just like that. All right, so once again, nothing new really, right? It's just translating, right? Shifting from how we get that information, all right, and from what context we get that information. All right, now, shaped like a V, well, that should tell us its absolute value. If it's shaped like a U, it'd be quadratic, okay? Opens down, okay? So now what I know is my rate of change has to be negative, all right? So y equals, and it has to be a negative rate of change. Now, here's what I mean by assuming that we're comparing to the parent function. Shifted to the left 5 units and down 3 units. So we're comparing that to where the parent function normally is, which is at the vertex. So what this means is if it's shifted left 5 units, that's moving the x part of our vertex. So that means it's going to be -5 if I go to the left of 0. And then down 3 units, if I go from 0 and go down 3 units, that's -3. And so that's my vertex, all right? So when I see shifted, all right, it's moving that vertex of the parent function from 0, 0 and creating our new function. And then now it says my rate of change is positive or -4. Well, we know we want the negative version because it opens down. So I'm going to take that -4. We know the vertex is -5, -3, so x plus 5, all right, and then minus 3. All right, now let's see if you guys can do this one. The parent function, right? So now we're talking about this guy, and we want it to reflect over the x-axis. Well, the parent function normally looks like this. Well, if we want to reflect it over the x-axis, we want it to look like this. So instead of opening up, we want it to open down. So what is the only thing that we need to change in order for that to happen? That is the a value, right? So instead of having a positive 1, we want that a value to be -1. And you can just put the negative there, or you can write -1. All right, so we got 3 more examples to do here, D, E, and F. So let's look at those. So opens down. All right, opens down. So we know a has to be negative. So y equals, and we know our a value has to be negative, it opens down. Now, once again, shifted to the right, 30. That means now my x is 30. Up 64 means my new y coordinate for my vertex would be 64. My rate of change is positive -5/3. Well, we know it opens down, so I have to take the negative version of my rate of change. And now if I plug in my vertex, there's my equation. All right, now this is where the exploration at the very beginning is to come in. So now notice we're going to see this words narrower and wider. All right, and when we see the words narrower and wider, we know that we have to adjust our a value. And here's what I want you to understand about that. That means there's lots of possible correct answers, right? Okay, so now let's talk about what that means. All right, so opens up. All right, so y equals, opens up, we know we had a positive rate of change. Now, notice, and I want it to be narrower than 5. Now, what I want then is if I want it to be narrower, I want it to increase faster. So I want a larger a value. So all you have to do is pick an a value larger than 5. Okay, so I'm just going to pick 6, make it easy. All right, and so there's my new a value. So it opens up because it's positive, it's narrower because it's bigger than 5. Now, once again, we still see the shifted to right 2, so that means my new vertex would be 2 for the x, and down 5 would be -5. So there's my new vertex. So then x minus 2 minus 5. Okay, now opens down and wider than. Now here's what I want you to understand. The positive, negative, whether it opens up or down, has no effect on the wider or narrower part. Okay, all right, so when we look at whether we want it wider or narrower, we want to just look at the number here. So if I want it to be wider, I need it to not increase as fast. I need a number smaller than 3/4. Okay, so a number smaller than 3/4 would be 1/4. So here's what I recommend is always adjust your narrow or wider based on your a value, and then assign it the sign you want to make it open up or down. Now I want to open down, so I'm just going to make it negative. All right, so the width doesn't matter if it opens up or it opens down, right? Things are either wider or narrower. Okay, so when we adjust that, we're adjusting the value of a, not the sign of A. Okay, so I would assign that last. And then notice it shifts to the left 7, so that means x is negative 7, and up 3, so there's my new vertex. So x minus negative 7 becomes plus 7, and then plus 3. All right, and so there's, all right, our lesson on working with absolute values and writing equations. We'll do a little bit more practice in class, so if you have any questions, make sure you write those down, ask those, and I will see you then.